The name of this lesson is Area and Perimeter of Parallelograms. We want to be able to calculate both the perimeter and the area of these parallelograms given side lengths and or the altitude. Okay, the altitude is another word here. It's listed as h for height. It means the same thing. So the formula for the area of a parallelogram is base times height. And so if you're given the base and the height, you just multiply them together. And then the perimeter is found by just adding up all the sides. So you can say add 4 sides, or since we know that in parallelograms opposite sides are congruent, sometimes we'll say, 2 times, some people call that the width, but just 2 times this side here, we'll call it x, and 2 times the other side here, which is y. So 2 times x plus 2 times y, but basically just adding up all the sides. Okay, let's look at example 1. Now here in example 1, they give us some measurements, and we know that opposite sides are the same. So if this is 10, this is 10, this is 8, this is 8, and they give us the height. The height is always drawn perpendicular. Okay, so in this picture, we have a base of 10 and a height of 4. And so the area is 10 times 4, or 40. And then the perimeter, again, we can do 2 times 10 plus 2 times 8. And let's see, we'll get 20 plus 16, or 36. Okay, but let me go ahead and try and show you in this picture. One thing that can get a little tricky here is a lot of times people are thinking of this as the base, and then they see that 4, and that can be the base, but this other side could also be the base. Okay, so when you're looking for the base, either side can be the base, but then the height has to be drawn perpendicular to that base. So we'll see that in another example. Let's look now at the quick check. Just please pause and try and do the quick check yourself. Okay, and this one here, we see the height is drawn to where the 15 is, and so that's going to be my base, but we're not specifically given the height. So we know we have this base of 15, and if the distance from here to here is 12, we can say 15 minus 12 and get 3. And now we can find the height by Pythagorean theorem. Now this is one of the basic triples, so hopefully you didn't have to do Pythagorean theorem. This is a 3, 4, 5 triangle. So that means that the height is 4. But if you weren't sure, you could have done 3 squared plus b squared is equal to 5 squared. Okay, so the height is 4, so the area is 15 times 4, or 60. And then the perimeter, you just add 15, 5. This would also be 15, and this would be 5. So that would be 40. Okay, we'll look at example 2. Here, they have drawn the height outside of the parallelogram, which is fine, because all we need is that the height is perpendicular to the base. And so you can see that this line here with this right angle is drawn perpendicular to this base. So what you need to do to be careful here is make sure you understand that 5 is the side of the parallelogram. Okay, so the sides are 5. This is 12, but the height, change color, this is going to be your height, is 4. And it is drawn to the base of 12. So 12 times 4 is 48. And then the perimeter is 2 times 12 plus 2 times 5. So 24 plus 10 is 34. So just be very careful on what is the side of your parallelogram and what is the height of your parallelogram. Okay, so let's look at this quick check here. We have everything we need, but we do not have the height given to us, so we'll have to find it. We have 21 for the side, so this side's 21, this side's 10, but we need to find the height here. So we can subtract this 6 from the 21 and get, oh, I'm sorry, don't really need to do that. I'm looking, here's our triangle, and we have the measurements that we need. We have a 6, and we can call this B, and then 10. So this is another triple, but you can do 6 squared plus B squared is equal to 10 squared. And it is the triple, 6, 8, 10. So the height is 8. The base that's drawn to this base here, 21. So 21 times 8 is 168, and the perimeter is 4262. Okay, have a couple more. Now I can already see, when I see this exact and approximate, I know exactly where they're going here. That means exact, we are going to be looking at some radicals, okay? Those are exact answers. So then the approximate answer will be when we put that in the calculator. So I'm going to draw this a little bigger right here, this triangle, because what you're going to see here is you are going to have a 30, 60, 90 triangle right here. Okay? And so you're going to have to use your rules of x to the square root of 3, and 2x. Okay, let me erase over here if I can. All right. So let's look. The base. The base is 6. Okay, so what we need is the height. And so we have over here a 4. Should change colors. So we have a 4, which is across from the 90. So across from the 90 is 4. Across from the 90 is 2x. So if 2x is 4, x is 2. And so the x goes right here across from 30, and then this side is 2 to the square root of 3. So that is the height. So the base is 6. The height is 2 to the square root of 3. Let's come back and do this in a minute. The area then is base times height. So just 6 times 2 to the square root of 3 is 12 to the square root of 3. And then the perimeter, we have sides of 6 and 4. 6 and 4. So we can add those, 12, 16, that would be 20. And then when we go back and they want the approximate height, just use your calculator and put 2 times the square root of 3. So let me do that. 2 times the square root of 3 is approximately 3.5. And the area, I'm going to put 12 to the square root of 3. 12 times the square root of 3, and that is 20.8. Okay, so when it says exact and approximate, be ready to find those radical answers that we've been working on. Okay, so let's go to the quick check. Please pause this one and try and see if you can do this yourself. Okay, take the picture of the 30, 60, 90, x, 2x, x to the square root of 3, and try and fill in and see if you can finish this yourself. Okay, I hope you paused. We have 33, 22, and so what we need, let me get a different color, is the height. So we have 22 is right here across from 90. So that is 2x. So x would be 11. That would make this 11, and that would make this 11 to the square root of 3. So our base is 33. Our exact height is 11 times the square root of 3. The area is 33 times 11. I didn't want to make a mistake. 363 times the square root of 3. Okay, that is, put that in the wrong spot. I'm sorry, that's the area. 363 square root of 3. Let me erase. The approximate height is 11 times the square root of 3. I'll just put that in my calculator. $19.1. And then the approximate area, I'll put 363 times the square root of 3. It's approximately 628.7. And then we'll just add up all the sides. 33, 33, 22, and 22, and I get 110 units. All right. The last part here, let's see, we just have these last two. If the area of a parallelogram is 456 and the base is 24, find the height. Here you just start with the formula, okay? The formula for area of a parallelogram is base times height equals area. So just fill in what they give us. They give us the area is 456. So instead of A, I'm going to put 456. And that is equal to base times height. And they gave us the base is 24 times the height. So now it's just a division problem. 456 divided by 24 is 19. And so please try and do the quick check. Let me erase so you can have some space here. The area, the formula, area is base times height. And just fill in. The area is 510. And they give us the height this time is 15. And we do not know the base. So you're just going to divide by 15. And the answer is 34. Okay, good luck. I think you'll do good on this.